My name is Viet, and my research is in quantum machine learning, meaning that I'm trying to do machine learning tasks on quantum computers. So quantum computers are special kind of computers that harness quantum effects to perform computations. One of these effects that I use is called superposition, where the qubit, which is the elementary computation unit, can be in multiple states at the same time. The architecture I'm using is able to take as inputs a superposition of states, where each state represents an input and its binary classification, and it can learn the function that produced this classification. So the architecture is a quantum circuit made of simple building blocks called gates, and by changing the gates we are able to learn this function. At the moment we are in the noisy intermediate scale quantum era, or NISQ era, meaning that the computers that are available at the moment are not perfect. And they are not perfect because the qubit is still subject to noise, which is going to corrupt the computations. So I'm studying the architecture in the quantum version of the probably approximately correct or packed framework. So to find the approximation, I'm using a version of a well-known quantum algorithm called the Grover's algorithm, which is a list search algorithm. So classically, if you want to find an element in a list of n items, then you have to go through the list, meaning that you have to perform n operations. Now with the Grover's algorithm, you start with a superposition of all of these elements, and now after square root of n operations, you will most probably measure the element that you're looking for. And although there are theoretical results stating that quantum methods are not going to outperform classical methods on classical data, it is interesting to see how my approach compares to these classical methods. Still, my research can be used to understand how to perform machine learning on quantum data, so data that are produced by quantum experiments, for example, as classical computers can struggle to handle this kind of data.